Okay, for section 5.3, day 1, I will look at 4 problems. We are now doing more than just simplifying, we are actually solving trigonometric equations. So I'm going to do 4 problems that are similar in terms of what they're asking you to do, just they require different steps. So we're going to find all solutions over the interval from 0 to 2 pi for all of them. And here's your first equation. It's secant x times cosecant x is equal to 2 cosecants of x. Second one, like I said, same thing, find all solutions over the interval, and the equation is 2 sine x plus cosecant x equals 0. Third one will be all the solutions from 0 to 2 pi of secant x plus tangent x equals 1. And then the last one will be finding the solutions of 2 sine squared x plus 3 sine x plus 1 equals 0 over the interval from 0 to 2 pi. Alright, so just a good sampling of problems. Alright, so first one says find all the solutions of this particular function over the interval from 0 to 2 pi. So when I look at that equation, I guess what jumps out to me is that I have 2 terms, one on the left side, one on the right side, and both of these terms have cosecant x in them. So I'm going to move the 2 cosecant x to the left side so it looks like this. So I'll have secant x times cosecant x minus 2 cosecant x is equal to 0. So I'm basically setting the function equal to 0 like we do for a lot of algebraic functions. And the reason I do that is now this term and this term both have cosecant in common, and I can factor it out. So if I divided that term by cosecant, this would cancel. I'm left with a secant of x. If I divided this term by cosecant, this would cancel. I'm left with the 2. And so I have cosecant x times secant x minus 2 is equal to 0. A lot of times you don't want to have 2 separate trig functions in an equation. For this one it's okay because when I factored it, each of them are in its own factor. So now if I set this equal to 0, cosecant x equals 0, and set secant x minus 2 equal to 0 separately, I don't have to worry about having 2 trig functions in the same equation because a lot of times that's not a good idea. Alright, just like before, anytime you're working with sine, cosine, tangent, any of the trig functions, you prefer to work with the sine, cosine, tangent. So I know the reciprocal of that is sine. So if I think in terms of reciprocals, I'm going to say that the sine of x is equal to, if I take 0 divided by 1 and flip it over, I know that's undefined. So this is not going to actually give me an answer. Over here, if I set this equal to, or if I get secant x by itself, so add 2 to both sides, again this is secant, I would rather work with the reciprocal, the cosine, so I'm going to change it to the cosine, which means I've in effect flipped the fraction over, so I have to do the same thing on the right side, that becomes 1/2, and now cosine of x equals 1/2, that's hopefully something we recognize on our unit circle. So the work that I want you to do for me is to draw yourself a little unit circle. It's cosine on the unit circle, so it's like an x value. It's a positive number, so that means you have to go to the right. So that means you're in this quadrant and this quadrant, the first and the fourth. Again, I don't care how accurate your picture is, I just need you to be in the right quadrant. And then go ahead and give me the answer. Notice they're asking for the restriction in radians, so don't give me degrees. If you want to think degrees and then switch to radians, you can do that, but try to think in degrees if you can. Cosine of x being 1/2, that's a reference angle of 60 degrees or pi over 3. That one is pi over 3. And then if you think about this one long enough, hopefully you'll get that this is 5 pi over 3. And so those are the 2 answers that you should have for this particular equation. So typically you probably get more answers here. It's just that this is undefined, so this one didn't end up giving me any answers, which is fine. Some of you might be looking at this and saying, can't I divide both sides by the cosecant of x? For this particular one, it would work, but you typically don't want to do that. The reason is this. Pretend like you had this equation, and you said, well, yeah, I could just divide both sides by 5x. And you're right. Sure, let's try that. If I divide by 5x, that would leave me with x, and that would leave me with 1. And you'd say, well, x is equal to 1. And sure enough, if you plug 1 in, it works. But that's not the only answer. And you end up losing the second answer when you divide by a variable or you divide by the trig function. Think if you move the 5x to the right side, or sorry, I guess left side, factor out the 5x instead of dividing by it, and now notice what you have. You actually have x equals 0, which you lost when you divided by it, and x equals 1. So what I'm trying to say here is I wouldn't divide necessarily to get rid of that term specifically. It's usually not the best idea. See if you can't simplify some other way. All right, on to the next one. Finding all solutions of 2 sine x plus cosecant x equals 0 over the interval from 0 to 2 pi. Again, I don't typically want two trig functions. They don't have necessarily anything in common, at least as they look right now. So the strategy I might use here, I don't have any squares in it. Even if I had a sine squared, that would allow me to change it into a 1 minus cosine squared. That's not cosine, so that's not all that helpful. I do know that this could be changed into 1 over sine. So I'm going to just rewrite this equation and say it's 2 plus sine x plus 1 over sine x is equal to 0. So I'm still doing a lot of the same ideas from the simplifying. I'm looking for squared terms. I'm looking to square a binomial. I'm looking to factor. I'm looking to do all those things. Just that didn't quite work here, so now I just rewrote this using sines and cosines. And what I'm going to do is I can do this two different ways, and I'll show you both. I can get a common denominator, so I can combine this into one term, and then I can just set it equal to 0 and solve. So if I do that, I'm going to have to multiply this by sine x over sine x so that I have a common denominator. And my common denominator is going to be sine x. My numerator now, if I multiply this out, is going to give me 2 sine squared x plus 1. And then I can cross multiply. Now because this is in the denominator, this is like a restriction. That means that when I get done solving, the sine of x cannot equal 0. If I do get that the sine of x is equal to 0, I would have to eliminate that, which you'll see here in a second if it happens. So I'm going to cross multiply, which will give me 2 sine squared x plus 1 is equal to 0. Alright, from there I can of course subtract 1, divide by 2, and I get that the sine squared of x is equal to negative 1/2. It's sine squared, so take the square root of both sides, and remember that when you do that, you're going to get a plus or minus answer. So you get plus or minus the square root of negative 1/2. All right. And so now I've got the square root of a negative number. That should give me a clue as to what's going to happen here. So let's take a look at maybe the other way I could have solved this. Another way I could have solved this is I could have said, let's move this over to the left side so that I have 2 sine x is equal to, it's going to be negative cosecant, or I'm going to change it into negative 1 over sine x. And then once I've done that, I can go ahead and cross multiply right here. And that's going to give me 2 sine squared x is equal to negative 1. And notice that that is exactly the same as what I have basically right here if I go ahead and divide both sides by 2. So it kind of depends on how you want to do it. The reason that it works out really nice doing it this way is because these are the same trig function. If this wasn't the same trig function, then this way might be a better idea. But it all depends on the problem. So continuing to solve, I'm going to get sine squared of x is equal to negative 1/2. Again, take the square root of both sides. That's going to give me sine of x is equal to plus or minus the square root of negative 1/2. So I end up with the same thing, which is good. I should. And then because I'm taking the square root of a negative number, I know I'm dealing with some sort of imaginary number, and we don't do that when we're dealing with 0 to 2 pi. I need to get a real number. So I simply have no solutions for this one. Now if that was a positive 1/2, then of course I would probably take the square root of both separately and say that the sine of x was equal to plus or minus, it'd be the square root of 1 over the square root of 2. Rationalize it so that you had plus or minus square root of 2 over 2. And then you would be in all 4 quadrants, and you would go from there. You would have 4 answers. You would have a reference angle of pi over 4. So you would say it's pi over 4, 3 pi over 4, 5 pi over 4, 7 pi over 4. Didn't happen because we had the negative in there, but if that was positive, you'd have to continue to solve it. All right, moving on to number 3. It's going to look similar to that one where I have 2 different trig functions being added together. And like that one, I can do this one a couple different ways. And like we've said before, when you're simplifying, go with whatever kind of comes to you. And then if it doesn't work in the end, you can always switch it. All right, I look at it and I'd say, well, it would be wonderful if those were the same trig function. Clearly they're not. I don't have a function squared. I don't have a lot of those properties I see. However, I do know that if this was squared, that I could change it into tangent. And I would like to have the same trig function. So I could square both sides. That's always an idea. And that's what I'm going to do here. However, when I do that, I don't want to have these trig functions on the same side. I want one of them to be isolated. Because if I square right now, I'm going to end up with, when I do the insides and outsides, I'm going to end up with 2 secant x tangent x. So I'm going to isolate one of them. In other words, I'm just going to subtract whichever one I want to. I'm going to subtract the tangent over to the right. And then I'm going to square both sides. Now keep in mind, like we said in the notes, anytime you square both sides, it's possible that one of the answers you end up with, or more than one answer that you end up with, doesn't actually work. So you're going to have to be careful. This is one where I'm going to have to check my answers at the end. Alright, so squaring this term, that's not so bad. It's just secant squared x is equal to, remember to multiply or FOIL that out, that's going to give you 1 minus 2 tangent x plus tangent squared x. Alright, now the reason I did that is I still have 2 different trig functions which I do not want, but I can change secant squared into a tangent squared term, and then I'll have nothing but tangents in here, which is good. Then I can go ahead and try to factor or do whatever else I need to. So I'm going to go ahead and look up my rules for the secant squared if I don't remember. And the secant squared, hopefully you do remember, but if you don't, look it up. It's tangent squared x plus 1 is equal to, if I rearrange the order here, it's tangent squared x minus 2 tangent x plus 1. And of course that quantity is the same as that one. So if I subtract it from both sides, it all just cancels out. And I get 0 is equal to negative 2 tangent x. Divide both sides by negative 2. That of course is not going to change anything. It's still going to equal 0. So now I look at this and say, well, okay, where is the tangent x equal to 0? Remember, tangent is y divided by x, so the y value needs to be 0 in the numerator. That means I'm looking at 1, 0, or negative 1, 0. I'm looking here or here. Again, I want to see this little unit circle to show me where you're looking. And so in terms of the answer, if you look at your restriction, it's 0 to 2 pi. We know that's the same thing. It's including the 0, not 2 pi. So I want to say 0 here, not 2 pi. And then this, of course, is pi. Now, like I said before, we're going to have to go ahead and check our answers, and we'll do that in a second. Alright, so 0 and pi are the 2 answers I got from that particular one. Alright, let's say I tried this a different way. Let's say that I did the same kind of strategy I did for maybe one of these back here where I got a common denominator and combined them together. I know this is 1 over cosine. I know this is sine over cosine. They already have the common denominator. So if I combine them, I would get 1 plus sine x over cosine x equals 1, and I could cross multiply here. Now the reason that I liked doing it back here was because they were, where is it? There we go. They were the same, right there, sorry. They were the same trig function, so when I cross multiplied I had nothing but sines. Of course the problem with this one is I still have a sine, I have a cosine. And the idea is, I'm going to do kind of the same idea I did here. If I had this squared, I could change it into sine. Or if this was squared, I could change it into cosine. So I'm going to square both sides here. Alright, that's going to give me 1 plus 2 sine x plus sine squared x is equal to cosine squared x. If I rearrange the order, I just always write the squared, I always write it in standard form, I guess. Right side, that would change into 1 minus sine squared x. The 1's, if I subtract 1 from both sides, they will cancel. If I add sine squared x to both sides, I get 2 sine squared x plus 2 sine x equals 0. And now I've got the same trig function. There's no number back here. That means they have sine in common. They also have a 2 in common. So I'll factor 2 sine x out, and that would leave me with sine x plus 1. And now I can solve this. I'll bring that up over here. So if I set 2 sine x equal to 0, of course I can divide both sides by 2 and it's still going to be 0. So you ask yourself, where is the sine equal to 0? Well, where I have a y value of 0, that's here and here. Looks awful familiar to that, right? So I know my answers are 0 and pi. Second part of that, what about when the sine of x is equal to negative 1? Where does that happen? and that happens here at 3 pi over 2. So when I solved it this way, I only got 2 answers. Solved it this way, I got 3. That might tell you something specific about what's going to happen to that. Remember, anytime you square both sides, you have to check your answers to make sure that you didn't introduce what they call an extraneous solution. So what I'm going to have to do is I'm going to have to go check my answers. So it's possible that these two both work. It's possible that I know this one probably is not going to work because it didn't happen over here. Doesn't mean that both of these work. Neither one of these might work, or one of them might work. So I need to plug it into, I always go back to the original function. So I'm going to plug 0 in for the secant. So now think on your unit circle. At 0 radians, I know the point is 1, 0. This is the cosine. If I take the reciprocal of it, it's still 1. So when I plug 1 in, I'm going to show it right here. Sorry if I'm squeezing that a little bit. When I plug 0 in, I'm going to get 1 for the secant, plus the tangent of 0, it's 1, 0. It's 0 divided by 1, it's going to be 0. So does 1 plus 0 equal 1? Sure it does. So I know 0 works. That one's fine. Let's try pi now. Secant of pi. Well, here's pi. The point is negative 1, 0. There's the cosine. If I took the reciprocal of it, it's still going to be negative 1. So now I have negative 1 plus the tangent. Y divided by x is still going to give me 0. Is negative 1 plus 0 equal to 1? No, it's not. Pi actually doesn't work. And then I'm pretty sure this one doesn't work because it didn't happen in this answer, and it would have needed to, but I'll plug it in to show that it doesn't. Plug 3 pi over 2 in, I'll just show it here. 3 pi over 2, this point is 0, negative 1. If I ask you for the secant, there's the cosine. If you flip that over or find the reciprocal of it, it's undefined. So I can't even check this anyway. So my only answer for this problem is 0. So it's one of those things where anytime you square both sides, you're going to have to check your answers. Try to remember to do that. It's easy to forget. If you forget and that's the only thing you did wrong in the problem, not a major issue, because you obviously understand what you're doing. You just have to be careful. All right, the last one that I'm going to do then for the first part of 5.3 is finding all solutions of this particular function. The good news when I look at this is they all have sine in them. So it's the only trig function I have, which is wonderful. And if you're getting good at looking at this function and being able to see this, well, then you know that you can probably use the quadratic formula on that. Well, if you can do it there, you can do it here. It's just that instead of x, you've got sine x. So if I think about playing around with trying to factor that, I can mess around, and I can eventually find out that it factors into 2x plus 1 and x plus 1. And now I can say, well, it's not actually x, it's actually sine x. So this is really going to factor into 2 sine x plus 1 and sine x plus 1. And again, you can do the little thing that we say where you multiply the front and back, or do the earmuff method. I didn't actually show it. I know what the factors are. There's not that many factors of 1, so this has either got to be 1 or negative 1. Not many factors of 2, so it was easy to guess and check it. But usually when you're doing this, I would suggest that you show the earmuff method. All right, once I've got that, then just set each term equal to 0. That's why you want this to equal 0. If it didn't equal 0, you would subtract or add whatever the stuff is over here so that it did equal 0. Because if this is equal to anything other than 0, I can't do this where I set each term equal to 0. So just like we always stressed when we were solving other types of problems, you want to make sure that you have that thing set equal to 0 if it's degree 2 or higher. Alright, so I solved both of these, and for the one on the left, I'm going to get the sine of x is equal to negative 1/2, eventually when I subtract the 1 divided by 2. The one on the right, I'm going to get the sine of x is equal to negative 1. So again, draw yourself a little picture to show me which quadrants you're looking at. And for the one on the left, sine of x is equal to negative 1/2. That's going to happen in 2 quadrants, as most of these do. It's sine, so it's like a y value. It's negative. It's going down. This is the one rarity where you only actually get one answer. Where do I have a y value of negative 1? It only happens here. And now I can go ahead and figure out what the answers are. Let's start with this one. Negative 1. This one is 3 pi over 2. So there's one answer. And then these two, it's a y value of 1/2. That means it's a reference angle of 30 degrees, or pi over 6. So this one would be 7 pi over 6, and this one would eventually be 11 pi over 6. So again, try to think in terms of reference angles if you can. It'll help you out. And then these are the three answers that I will have. I didn't square both sides. I didn't have anything in the denominator, so I don't have to worry about checking if my algebra is right. These will be the right answers, and they are. Hopefully that helps you out with your homework for the first half of 5.3.